Everyone, I'm going to explain my first experiment of MLT lab. In this notebook, it contains 30 different analytics tasks, including data understanding, outlier decision, correlation analysis, and skew thickness. My first question is checking shape. I used a DF shape to check the number of row and column. This tells us how the size of the data set. And my second question is identify the column type. I use the select D types to separate the categorical and numerical columns. Object type means categorical data like a gender or city. The number type of means numerical like age, tax, quantity. This helps us to understand data structures. And my next question is a numerical column that display the min, max, and mean. Here I use the aggregation function min, max, and mean. It calculates only the numerical column. It won't calculate the categorical column. The five number summary for age box plot. Uh, I perform a five number summary for the age column. This includes minimum, first quartile, median, third quartile, and maximum. Then I plot the box plot. The box represents the IQR. The line inside the box represents the median. Points outside the are outliers. Outlier. My next question is outlier deduction using IQR. I calculate Q1 and Q3 using quantile function. Then I compute IQR as Q3 minus Q1. Next, I define the lower and upper limits using Q1 minus 1.5 times IQR, Q3 plus 1.5 times IQR. Any value outside the range is considered as outlier. And my next question is set square method. I also detect outlier using set square. Set square measure how many standard deviations value from the mean. If the absolute set square is greater than 3, it is considered as an outlier. This method works well for normally distributed data. And my next question is related to correlation. I calculate correlation using DF correlation. Correlation value ranges from -1 to 1. 1 means a strong positive relationship, -1 means a negative relationship, 0 means no relationship. This is a high display the feature pair with a single highest positive and negative correlation. I, I unstack and sort the correlation matrix to find highest positive and negative correlation pairs. Then I filter value greater than zero point 0.6 or less than minus zero point 0.6. This helps identify strong relationship between features. And this question also related to same with the value greater than 60% for the input feature. And my next question is analyzing the skewness of the feature using the plot distribution. I calculate skewness for the tax column. If skewness is greater than 0, data is right skew. If it is less than 0, it is left skew. Then I plot a histogram with KD curve to visually check the distribution. Here is my distribution of the tax, which is the right skew. Perform a univariate analysis and a categorical variable city using the bar. So here's my city, x is equal to city, data is equal to df. The title is city I given. The plot is shown as here. Univariate analysis. I use a count plot for city column. This show how many observations belong to each city. This is a continuous variable. I use a swarm plot and a Weiland plot for rating column. Swarm plot shows the individual data points. Weiland plot shows a distribution and density. Here is the plots. This question is have a categorical is continuous. I use a box plot to compare the age across gender. This helps understand distributed differences. This is a categorical variable and continuous variable of gender and age. And next question is bivariate analysis. Multivariate analysis. I use the pair plot with the hue equal to city. Pair plot shows a relationship between multiple numerical variable at once. Part B, data pre-processing column. It finds the missing value of the null values. So here's df dot is null dot sum of it. It replaces the missing value into null value. Mean implementation for a numerical column with a small missing percentage, I replaces missing value with the mean. Mean implementation for numerical columns with a small missing percentage, I replace missing value with the mean. Interpolation imputation for a numerical columns. Here for I use the nearest interpolation method to estimate the missing value based on the nearby value. Some mode implementation of a categorical column less than 10 percentage. It calculates seasonal and uses the sum of method to see how much the imputation method is replaced. Here says drop rows with the set scores less than 3 for a guarantee period. Here is a dropping outliers I mentioned here, and you have a duplicate function in the set score section. After dropping the outlier is before dropping the outlier is 51 and comma 15. After dropping the outlier is 47 comma 15. Percentage of a duplicate row and all column. Duplicate count that it has a df dot duplicated sum and duplicated percentage. It is a len df into 100, and the duplicate percentage is 3.92156862. The drop duplicate row. Here it dropped the every duplicated row before it drops the 51 comma 15. After drops it's 49 comma 15. Here as a subset duplicate percentage is 15.628. Drop the duplicate 25 from the question 25 and display the size before after dropping. Here before dropping 51 comma 15. After dropping the subset is 43 comma 15. Here is to find the min max normalization for the numerical feature age using Python code analysis. Here is the plot is mentioned with the min max, and it's a title as min max. X label is index and the y label is normalized value, and the plot is shown here. To perform a set score normalization for a numerical feature age using the Python, it's a scatter plot, and the title is mentioned as a set score normalization, and the x label is index and y label is set score value. Here is the label encoding categorical feature payment, and the label encoder is here. And the last, the question is one hot encoding for a categorical feature payment using the Python. Here is the dummies payment of the credit card and a vault. Thank you for